Hi and all. This is Kesaketri from D section. Today my topic is parallelization in Python. Parallel processing is a mode of operation where the task is executing simultaneously in multiple processors in the same computer, same as multiprocessing. It means it means to reduce overall processing time. However, there is usually a bit of overhead when communicating process, which can actually increases the overall time taken for small tasks instead of decreasing it for some small tasks. In Python, the multiprocessing model is used to run independent parallel process by using subprocess instead of threads. That means breaking the process into subprocess. It allows you to leverage multiple processors on a machine, both Unix and Unix. So both Windows and Unix, which means the processes can be run in completely separate memory location. The maximum number of process you can run at a time is limited by number of processors in your computer. If you don't know how many processors are present in a machine, the CPU underscore count function is multiprocessing will show it. That means the number of CPUs in the machine. In parallel processing there are two types of executions. One is synchronous and asynchronous. Asynchronous execution is one of the process or completed in the same order in which it is started. It was started. This is achieved by looking the main program until the respective process are finished. Asynchronous, on the other hand, does not involve locking. As a result, the order of results can get mixed up by usual gets down quicker. There are two main objects in multiprocessing to implement parallel execution of a function: poll class and a process class. Actually, the poll class, synchronous execution, poll.map and poll.star map. These are two functions, and the poll.apply. And asynchronous execution, poll.map asynchronous and poll.star map async. Second one is poll.apply of async. Process class. Let's take a type of typical problem and implement parallelization using the above techniques. In this, we stick to the poll class because it is a most convenient to use and serves a most common practical applications. Actually, uh, the first program is given 2D matrix or a list of it may be a 2D matrix or a list of lists. Counts how many numbers are present between a given range in each row. It's a normal range of numbers that are present in each row, and we will work on list prepared below. Here are the sum of the program of the first program. First one is import numpy as np. We'll import here numpy library from time import time. So commit is prepare date np.random.random state of 100. That means we are preparing up to 100 numbers. That means range is 100, and array of np.random.randint of 0 to 10, size of 20,000 to 5. uh, Data equals to array of two list. That means we are creating the list, list of the arrays. Sorry, yeah, list in the arrays equals to data, and we are dividing up, we are slicing up to 5. The general way to parallelize any operation is to take a particular function that should be run multiple times and make it run parallelly in different processors. To do this, you initialize a poll with n number of processes and pass the function uh, you want to parallelize to one of the poll's parallelization methods. Yeah, multiprocessing.poll provides the apply function, map function, and star map function methods to make any function run in parallel. So, what's the difference between the apply and map? Actually, both apply and map takes the function to be parallelized as the main argument. That means both functions. That means apply and map two functions are function to be parallelized to the main argument, and but the difference is apply takes an arguments that accepts the parameters passed to the function to be parallelized as an argument. That means whereas map can only one iterable as an argument. That means apply function takes the many number of arguments, that means args, there are parameters that are passed to the function to be parallelized, but map function can only take one iterable as an argument. So map function is really more suitable for simpler iterable operations but does the job faster. We will get the strap map once we see how to parallelize how many within the range, that means the how many within the range function with apply and map functions. Let's parallelize how many within range function using multiprocessing dot pool. Parallelizing using pool dot apply. Import multiple processor as MP, multiprocessing as MP. That means you are importing the multiprocessing library here. And step 1, initiating the multiprocessing dot pool function. That means pool equals to vc mp dot pool of mp dot cpu count. That means here you are counting the number of cpus in the system actually. Step 2 is pool apply the how many within the range. Result equals to pool dot apply how many within range of arguments of row of 4 comma 8 for a row in a detail. Step 2, don't forget to close, and here when you're opening the pool function you have to close it. So pool dot close, and printing, we are printing the result. Pool dot map accepts only one iterable as an argument. So as a workaround, I modify the how many within the range function by setting a default to the minimum and maximum parameters to be created a how many within range row only function. So it accepts only an iterable list of rows as input. I know this is not a nice use by case of map, but it clearly shows how it differs from apply. And here like pool dot star map also accepts only one iterable as an argument. It's unlike the pool dot apply. Pool dot map and pool dot star map are the two same functions that accepts only one iterable as an argument, but star pool, each element is an iterable, is also an iterable. But when you come to the argument of the star map function, the iterable itself is also an iterable, and you can provide an argument to the function to be parallelized. That means the arguments which we used in the pool dot apply function in the same order in an inner iterable element will turn into an unpacked during execution. So effectively, pool dot star map is like a version of pool dot map that accepts the argument. That means here the pool dot star map is a version of pool map that will accept the argument within the iterable, which is itself an iterable. So far you have seen how to parallelize function by making it work on a list. But when working in the data analysis or machine learning projects, you might want to parallelize the panda data frames. That means here we are using NumPy because NumPy is an library which you use to do the operations on arrays actually. So that is here we are using panda data frames, the data frames which are more than the arrays. That means graphs, trees, etc., that we use in the machine learning projects and data analysis projects. But when we come to the table data, that means when we come to the arrays, we only use NumPy array libraries. So when it comes to parallelizing a data frame, you can make the function to be parallelized to take it as input parameters. One row of the data frame, one column of the data frame, the entire data frame itself. That means here we can take the inputs as a one row or one column or the entire data frame time itself. Thank you.